Well, here it is, the state diagram for machine M2. There are seven states. Is it one? Well, you can't see 1, 2, 3, 4, 5 ordinary states and 2 halting states. Here are the 2 halting states: the accept state and the reject state. The starting symbol, the starting arrow, the start state indicator, or whatever you want to call it. So the start state's Q1. But here's your starting arrow. So you start here. So it looks pretty much like the state diagrams you've seen in the past, except the labels on the transition arrows are a bit different, and I'll need to explain. They'll be here. I'll need to explain how to interpret those labels on the transition arrows. Other than that, it looks fairly usual. Now this is a fairly simple example of a Turing machine. It's a first detailed one, but even so, you'll quickly see. You'll see what I mean. That the details mount up fast. With this machine, for a given string input, we'll input the string 4 zeros, okay? And we'll step through configuration by configuration, a sequence of configurations, until we get to the accept state. And you will see there are already a lot of details. Now in this session I will not go into every detail. I'll leave that to you as homework, because there are a lot of them. I'd be here for an hour or more, perhaps, if I did. Maybe more. So what you need to do now is, if you're taking this seriously, is you need to study this. Ask yourself, well, at various levels, right? At the high level, global strategy level, you ask yourself, what's the machine doing, and how does it do it? And then once you're fairly clear on the algorithm, if you like, the major, the top level, and then with top down you design, you then try to translate the big picture, so to speak, in terms of finer level details, the details. I mean, you can examine, for example, you go from a particular state here to the next one via this Turing machine step. Right? So in a sense, what's going on here, these labels indicate steps. Well, it's not only the label. You need the start. Well, the from state and the to state and the label. You need those 3 things to describe a step in from one configuration to the next in a Turing machine. So you need to understand at that level of detail, why is this doing that via this, that kind of stuff. So there are multiple levels that you need to be thinking at when analysing a Turing machine, and similarly when you're designing it. Designing it is even harder. You have to decide the number of states and why you put in another state to do what, and like I say, it's an art, right? So in some ways this looks fairly familiar. So now let's talk about the interpretation of the labels on the transition arrows. So okay, so let's take this one. So we're going from state Q1, starting state in fact, to Q2, and what does this label here mean? Well, the convention is, you look, so typically it'll be something, arrow something, comma something, right? And even this will get abbreviated to, well, something like this. Look, here there are only 3 things. Right? So here you've got 1, 2, 3, 4, 5 marks of some kind. Here you only got 3. So this is a shorthand of something like this. So we'll talk about the shorthand of the shorthand later. Okay, deal with this one first. So how do you interpret this? Well, obviously you're going from Q1 to state Q1 to state Q2 because it's a state transition diagram, state diagram, right? So that you're familiar with. You know that. So let's concentrate on what this means. What does this mean? Well, this is the first symbol here is what you're reading, what the head is reading on the tape. Arrow, well, no, that'll become clear in a minute. And this symbol is what you write on the tape. So in other words, whatever's here, if you're in this, if you're reading that one, that one here, in this case a 0, well they're all zeros for this example, that will be overwritten by this one. Okay? And the comma, well, it's so a separate thing. And what this is the move, the instruction. Do you move left or right? And R is to move right. Now, don't confuse the R's and L's. Well, the L's pretty obvious. Here's some L's here. The R in this context means right, as opposite from left. The R in this context is reject. Okay, I guess that's pretty obvious. Alright, so what's going on here? So if you're in state Q1 and you're reading, the head is over the square containing a 0, then, that's what the arrow would be then, then overwrite it with the symbol here, which is blank. In other words, overwrite the 0 with a blank. Put a blank where the 0 was. Okay, that's what.
Avast virus database has been updated.
That's what this is saying. And once you've done the writing, then move. Okay, and you'll move right. Okay, so you have a transition rule. So you can write what's just been talked about. You can write that in the form of a transition rule. Here, have a look here. Here it is. Here it is here. Okay. So putting labels like this is just a sort of shorthand of your transition rule. So here's your delta function. You're in current state is Q1, and you're reading. The head is reading the symbol 0. Okay. Here's your 0. Okay. And the transition function will output a triple. Like an instruction of what to do next. Okay, you'll switch to state Q2. That's like next state is this. So arrow to Q2. Okay, this tells you what to write at the current position, current square on the Turing machine. So you write blank. So what was 0 gets overwritten by blank. Okay, and then move 1 square to the right on your tape. You move the head 1 square to the right on the tape here. Okay, so that's what's going on here. All right, now the abbreviation. Like, well, let's use the one here. Have a look at the transition from Q3 to Q4. Q3 to Q4. Okay, so 0 arrow R. Now that's even shorter. There's only 5 marks here. 3 marks here, and there were 5 here. So what's this mean? Well, this 0 arrow R is shorthand for 0 arrow 0, comma R. Okay, so so the shorthand is leaving out finger 3 and 4 from your viewpoint. Okay. So, and what does that mean? How do you interpret that? Well, so you're in state Q2. Oh, sorry, you're in state Q3, and you're reading a 0. then you will write the same symbol. So you'll write a 0. So in other words, the symbol on the tape does not change. Comma, and then you move right. Okay. So when you have like 3 marks in your label, it means do not change the symbol on the tape, effectively. Now let's see if we can find a different one. Yeah, here. Here. Now we've got an X on the tape. So, and it's just X arrow R. So what that means is you're, well, in this case, so you're in state Q3, you're reading an X on the tape, then write X on the tape, so don't change anything, comma, and then move right. Okay? Hope you absorbed that. Alright. Okay, so from this via that comment to this state, we can write that in terms of a transition rule, and here it is here. So you're in the state Q3, current state, you're reading a 0. You're reading a 0, right? Then the transition function in that situation will return the order triple. It will tell you, so set of instructions if you like, to do 3 things. Transition to the new state Q4, so now you're here, that's the new state. Write 0 onto the tape, where the head is, but it was 0 and you're writing 0, so effectively the symbol on the tape at that square, on that square, does not change. Okay? And then move right, 1 square. Alright, so you've got the format now of the Turing machine state diagram, state transition diagram. That's an example. Now if all the states are there and all the labeling is correct, you then have a complete picture, complete